Let's do ArrayList Worksheet 4. You read over the documentation here to realize that a coin is really a value and a name, such as $half would be the name and the value would be 0.5, or the name could be a quarter and the value could be 0.25. So we have a double and a string. Okay, we're supposed to implement an equals method. The equals method needs to check both the name and the value, so we need an if statement. And in that if statement, we need to check both parts of the object. But what are we really comparing here? We're comparing the current object, which we call this, and we're comparing its value, if this dot my value is equal to some other coin's value. That other coin that we're talking about is given the parameter name a coin. So we need to check that coin's value and to see if they're both equal. The word this is optional here, so it could be written simply as if my value double equals a coin dot my value. But that's not enough. We have to also check their name properties. So you need to use the and symbol here, and to compare their name properties, you're checking this object's name, and you can't use the double equals. You have to use the equals method that's built into the string class. So there is one way in which we could write this if statement's control expression. And that's a dot right there. And you could have the optional word this in front of my name like we did with my value. Again, that's optional. If you want to, you could use the getValue accessor method here instead of directly referencing the myValue property. Because we're currently in the class coin, you can refer to myValue both for this object and the parameter a coin. That's both; those are both legal. But you could also have written, so this is optional. You could have done this dot getValue, empty parentheses, and you could have used the public accessor method getValue. And of course you could have used the getName method down here instead of my name. What do you want to do if you've tested two coin objects here and they're equal? Well, you want to return true, because this method must return a Boolean, and you would simply return true. It would be perfectly fine to write the else clause and else return false, but because we're in a method, we could just write return false and be ensured that the only situation in which this line of code would execute is if this control expression was false, and therefore the return true was ignored, and the computer would have no option but to execute this line of code, which is what you want. Do keep in mind here, or let me point out, that as part of this answer here, we used the equals method, but we were implementing an equals method. Well, this equals is something that you would use in a client program, public static void main string args. And somewhere in a client program, you would have two coin objects, and those two coin objects would, at some point in the code, need to be compared to each other. So you might have if A dot equals parentheses B, etc., etc., etc. So this equals method here is invoking the equals method from the coin class, because A is a coin, and therefore this client program would be calling this equals method, and the B would be passed as a parameter and plug in for a coin. That's the explicit parameter. And the A is, indirectly at least, being passed to this class, and it is known as the this object, or otherwise called the implicit parameter. So the object variable here before the dot matches up with this, and that which you have in parentheses here, the other coin object, it's the explicit object. Moving on to the next piece that we have to add in this worksheet. Well, before we get down there, notice that a pers class is typed out here, and it has an array. So here might be your pers, but within there, there's an array list, I meant to say. And this array list named coins has coin objects in it. So further complicating the diagram here, in each element of the array list, we have a coin object. And, of course, this list has a size at any given point while we execute code in the future here. So the size there would be 5, positions 0 through 4 of the array list named coins. And each of these coin objects have a name and a value. Name and value. So keeping in mind here that this is an example of has-a relationship, where you would say that pers has a coin. And indeed it has multiple coins, but we just say pers has a coin. And this is an example of composition in the Java programming language. Well, we need to now turn to the next page and see what code we actually have to execute right here and implement in this part, get total. Very common thing that you'd have to do in the AP exam. You'd need a linear search here and go through that array element by element and look up the values, perhaps 25 cents, 10 cents, etc. And you'd have to get a running total of all these coin objects and add them into a value, into a variable, and return that variable. So I need such a variable, and I'll just name it sum. We initialize it to 0, and we need a for loop. You could either use a traditional for loop or an enhanced for each loop. I'll first do this with an enhanced for each loop. If to do that, you would use a colon, and the name of the array list is coins. That's the instance variable that we're traversing through. And each coin in this array list, each coin object, I just give it a name X perhaps, and they are coin objects, so I'm declaring it here as a coin. And I'm assuming from left to right, starting at 0, but that might not be accurate. It might not execute this way behind the scenes, but it probably does. Anyway, we first take this quarter, and it's stored in the variable X. And we want to add into our running total sum the value that's stored in this coin object, that is the 0.25. And this coin object is known as X at this point in my tracing of my algorithm. And I need to pull the value out of that by calling the getValue method from the coin class. And I need to, well, that's it. That will work. Semicolon, and that will add it in. After this coin has been added into this running total sum, the for each loop just knows to continue, and the 10 cents gets plugged in for X, and then the 5 cents gets plugged in for X, and this loop traces over and over again until the total is in sum. Now don't forget, because they'll take a point off on the AP exam, don't forget to return sum. that grand total that you have, the money, the sum of the money in this purse needs to be returned because that's what the job of this get total method is to do. This is fine as one way of executing this or implementing this method, get total, but I could also have used a traditional for loop. And this traditional for loop could be used, this traditional for loop could be written with the local variable I, perhaps in I equals 0, I less than coins.size, which is something we do have to do with, we do have to check with this version of the for loop. And then of course semicolon I++. If you're more comfortable with this kind of a for loop, that's fine. You'll get full credit on the AP exam as long as you write the correct code inside the for loop here. I know it's sloppy, but it says for int I equals 0, semicolon I less than coins.size, empty parentheses, semicolon I++. Now that will also traverse through this complete array list, and we have the chance then to take each coin at a time. But to refer to these coins now, we have to go through the name of the array list, coins, and do a .get parentheses I. This notation is sort of equivalent to the X over here. It's a little bit more awkward doing it this way, but it gets the same job done. And now we have to call the getValue method with this coin that we just pulled out. And of course we have to add that into the variable sum. I'm sorry, but I did not indent correctly there. We would need to do something like sum plus equals all of this. GetValue is a method. I need parentheses, and of course I need a semicolon. That's it. The rest of this is the same. We would still need return sum. We still need to initialize sum to 0, and there's a perfectly good answer as well. Moving on, we need to implement the count method. And I'll do that. Again, the idea is the same. We might need to declare a variable up front. This can be an int because we're counting up how many nickels or how many dimes we have. It's going to be a whole number. I can't use the variable name count because the name of the method is count, so maybe I'll just name this num. Set it equal to 0. I need my for loop. Again, you can use either kind of for loop. I will choose to use one of these for each loops, we'll say. So for coin x colon coins. And for each coin, I'm going to check to see if it is indeed equal to a coin. So if x dot equals parentheses a coin. We are taking advantage of the equals method. Whoa, sorry about that. We are taking advantage of the equals method that we implemented on the previous page of this worksheet. So that equals method only works because we've already written the code earlier in the coin class that makes that work. So each coin from our array list will get a chance to be compared with a coin to see how many of them are nickels. And each time we get to a nickel, we need to add 1 to this variable num. So if all of this is true, we simply do num plus plus, semicolon. And after the formality of those curly braces that I wrote in there, we would just return num. And num is guaranteed to be the number of A coins that are in our array list coins. Again, this could be rewritten with a traditional for loop, but you would have to use coins.getI anywhere that you're using x. Moving on to the last method that I have to implement here on this worksheet. This is a tricky one, because what if the, actually for all of these, no, it's just this one that's tricky, I'm sorry. If there if the array list is empty, which conceivably could be the case, if its size is 0, we have to make sure that this program does not crash. And so let's just do that check. If coins.size is equal to 0, then return, let's just return empty string. It would probably tell you what to return in the question if we had looked at the question directions. But let's just return two quotes next to each other, unless we are told otherwise. Else, now here's where we do all of our work. This is another linear search. I need to keep track of the smallest number that I have so far. So I need a variable to double, and I'll call it smallest value, or min, but it's too late. I already started writing this out. And I'm going to set that equal to a big number, like 2 billion. But that's sort of crude. So I'm going to set it equal to whatever value coins.getZero has. The first coin in my array list is coins.getZero. And I'm taking its value, which in the example above is 0.05, and that value is being stored in the variable smallest value. So we're assuming that that is the smallest number, and then we'll leave it to the rest of the elements of the array list to prove that it's not the smallest. So with that line of code having been written, I'm going to leave a blank line there in case I need to declare any other variables. I hit my for loop. And for this one, I'm going to use a traditional for loop. It's best to be safe when you're doing this kind of algorithm to make sure you go left to right and hit every element. It probably would work with this kind of for loop, but I'm just going to mix it up a little bit here. For I equals 0. No, we don't have to start I at 0. We'll start I at 1 because we've already inspected the element in position 0. So we can save a microsecond here. And we'll take I up to coins.size, or just less than it. And we'll do the old standard I++ to make sure we're going we're incrementing by ones through this array list and we don't miss any elements. If coins.getI.getValue is less than smallest value, we have a new smallest value. I need to put I here in these parentheses and not the number 1 or some other magic number. And I still need to call getValue, and I need to check to see if that element expression is less than my current smallest value. If it is, we have a new winner. We have a new smallest value. So we go into the curly braces of this if statement and we overwrite smallest value with this new value. This is tedious, and there are other ways to do this by using extra variables here, but I'm packing it all in and I'm running out of room, so it's a good thing that I'm trying to squeeze it in. Ultimately, we want to return the name of the value. So I need to keep track of what the name of this coin is. A good thing, one way to do that would be to have a variable called name, and I'll just set it equal to whatever coins.getI.getName happens to be at that precise moment when I found a new smallest element. And this reminds me that I was incomplete up above. I should also have a string variable here called name. and I'll set it equal to coins. I'm just using ditto marks to save time here. Coins.getZero.getName. Don't use ditto marks on the AP exam. I'm only using it to keep this video short. So having trapped the name in this special variable name of perhaps a nickel, it's being overwritten with some name of a smaller coin. We're done with that if statement. We're done with this for loop. And at the end here, where I don't really have any room, I will return name. That is done outside of this loop, and we're sure that we've inspected all the elements. But this line of code is inside the matching curly brace here to this else.